Hi guys, welcome to Ply Planet, and in this video we'll be learning about Euclid's division algorithm and we will also solve exercise 1.1. तो चलिए शुरू करते हैं. So normally in any division process we continue the division process till the value of r is either equal to 0 या फिर वो हमारे divisor b से छोटा हो जाता है. And when we reach such situation, we can express the relationship as A is equal to B cube plus R, where R is either equal or greater to 0 or less than B. And that's called as Euclid's divisional lemma. Now using this lemma, Euclid actually created an algorithm to find out the HCF of two numbers, and that was called as Euclid's division algorithm. And that says the HCF of two positive integers c and d, where c is greater than d, can be identified by following steps. And the step number one is that we express c in the form of Euclid's division lemma, and that is c is equal to bd plus r. And if r is equal to 0, then d is the HCF of c. And if r is not equal to 0, then we'll apply the lemma again on, and we'll continue the process till we get the value of r equal to 0. And in that stage, the divisor will be the HCF of c and d. तो अब हम लोग यहाँ से आगे बढ़ते हैं. Let's begin with the exercise 1.1. Alright, so question number 1 says that we need to identify the HCF of these numbers using Euclid's division algorithm. तो हमारा जो सबसे पहला सेट है that is 135 and 225. Now here we see that 135 is lesser than 225. So let's apply the Euclid's division algorithm on this, and in that case we will be writing that 225 is equal to 135 multiplied by 1 plus 90. Now in this case, if we see that r is not equal to 0, so hence we will again apply the lemma on 135 and 90. So now here the value of r is equal to 0, and at this stage the divisor is 45. So we can say that 45 is the HCF of these two numbers 135 and 225. Similarly, now let's take the second case. So the second case is 196 and 38,220. Now let's apply Euclid's division algorithm. So it's coming to 38,220 is equal to 196 multiplied by 195 plus 0. Now since the value of r is equal to 0, we can say that 196 will be the HCF of 38,220 and 196. So the next case is 867 and 255. तो यूक्लिड डिवीजन एल्गोरिथम लगाने के लिए चलिए डिवाइड करते हैं 255 से 867 को. तो इसमें देखते हैं हम लोगों का जो क्वेश्चन आता है वो 3 आता है, और इट बिकम्स लाइक दिस दैट 867 इज इक्वल टू 255 मल्टीप्लाइड बाय 3 and the remainder is going to be, and that's how it becomes the that's how it gets expressed in the form of Euclid's division lemma. तो हम लोगों ने यहाँ पे ये किया. Now since r is not equal to 0, we will again apply lemma on r and also on b. So in that case situation, it will become something like this. So it will become like 255. So it will become 255 is equal to 102 multiplied by 2 plus 51. और यहाँ पर भी r की वैल्यू 0 नहीं आई है. So again we'll apply the lemma on 51 and 102. So let's apply that. So we'll write 102 is equal to 51 multiplied by 2, and when we do that, then we see that r is equal to 0. And at this stage the divisor is 51. So we can say that 51 is the HCF of 867 and 255. So this is how we have solved the question number 1. Now let's move on to the question number 2 of this exercise. Okay, so question number 2 says, show that any positive odd integer is of the form of 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Let's consider a is some positive odd integer, and when we apply Euclid's division algorithm on this, then we can say that a is equal to 6q plus r, where r is either equal to 0 or greater than 0, or it will be lesser than 6. So what we can say is that the value of the r will be either 0, 1, 2, 3, 4 or 5, right? That means a can be written as 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. This is what we can write as the value of a. Now since a is a positive odd integer, that means a cannot be 6q or 6q plus 2 or 6q plus 4, because these three forms are divisible by 2. So we can say that any positive odd integer can be in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. So this is how we have solved this question. Now let's move on to the question number 3. क्वेश्चन नंबर 3 में हमसे ये कहा जा रहा है कि देयर इज एन आर्मी कंटिजेंट जिसके अंदर 616 मेंबर्स हैं, एंड देयर इज एन आर्मी बैंड व्हिच इज हैविंग 32 मेंबर्स. Both these groups have to march in such a way that they march in equal number of columns, and that to the maximum number of columns. Both the groups have to march in the same number of columns. So what is the maximum possible number of columns in which these two groups can march? We need to find that. चलिए तो देखते हैं. Now since the number of columns need to be maximum, same for both the groups, right? So we can say that we need to identify the HCF of these two numbers, 616 and 32. So let's quickly do that. We have already done it in previous question. We'll put the Euclid's division algorithm in this and we'll find it out. So at this stage, the value of r is equal to 0 and the divisor is 8. That means the HCF is 8. And that means the possible common number of columns for both the groups can be 8. So now let's move on to the question number 4. Using Euclid's division algorithm, we need to prove that the square of any integer, of any positive integer, is of the form of 3m or 3m plus 1. तो चलिए देखते हैं. In this equation, let's consider that integer as a and b is equal to 3. And in that case, we can say that a is equal to 3q plus r, where r will be having three different possible cases. Either when r is equal to 0, then a is equal to 3q. When r is equal to 1, then a is equal to 3q plus 1. And similarly, when r is equal to 2, then it is 3q plus 2. And now we will consider the case of a square. तो चलिए पहला वाला केस देखते हैं जहां पर a is equal to 3q है. So when a square को हम कंसिडर करते हैं, then it becomes 3q whole square, that is equal to 9q square. तो हम इसको इस तरीके से भी लिख सकते हैं, where m is equal to 3q square. और यहाँ पर जो वैल्यू m की होगी वो हमेशा एक इंटीजर की होगी, because we know that both q and 3 are integers, and the addition and the multiplication of the two integers always gives us an integer. That means m जो होगा वो हमारा एक इंटीजर होगा, राइट? तो चलिए अब यहाँ पर दूसरा एक केस ले लेते हैं जो हमारा सेकंड केस था, where r is equal to 1 is equal to 3q plus 1 and whole square. So that becomes 9q square plus 1 plus 6q, and we can also rewrite it in this form. और अगर हम लोग ध्यान से देखें, then it will be like 3 multiplied by 3q square plus 1, जहाँ पर m की वैल्यू होगी 3q square plus 2q. Now here m will always be an integer because q is also an integer, and rest all the numbers like 3, 2 वो सब भी इंटीजर्स हैं, और जब इनका एडिशन और मल्टीप्लिकेशन होगा तो हमें रिजल्ट भी एक इंटीजर मिलेगा. So that's why we can say that a is equal to 3m plus 1, where m is some integer. And now we'll take the third case. And the third case is equal to 3q plus 2 whole square. and we can rewrite it in this form, and we can finally write 3m plus 1, where m is equal to this particular expression, and m again will be an integer because ये जो पूरा expression है इसके अंदर q और जितने भी numbers हैं वो सब integers हैं, right? So this is how we have proven. Now let's move on to the question number 5. Alright, so in question number 5, using Euclid's division algorithm, we need to prove that the cube of any positive integer is of the form of 9m or 9m plus 1 or 9m plus 8. Alright, so let's consider a is some integer and b is equal to 3. And in that case, when we apply Euclid's division algorithm, it is a is equal to 3q plus r, where r will be of values either 0, 1 or 2, and in that case we'll have three different values of a. So let's see what it will be. So for r is equal to 0, a is equal to 3q, and for r is equal to 1, it will be like 3q plus 1, और जब r की वैल्यू 2 है then the value of a होगी 3q plus 2, right? And now let us consider the cases of a cube. चलिए तो पहला केस लेते हैं और वो बनेगा a cube is equal to 27q cube, और उसको हम लोग सिंप्लीफाई करते हुए इस तरीके से लिख सकते हैं, and it will be 9m, where m is some integer because q is also an integer, और उसका कोई भी एडिशन मल्टीप्लिकेशन का फंक्शन हमेशा इंटीजर ही बनेगा. So we have proven the first case. Now let us move on to the second case where r is equal to 1. So it will be a cube is equal to 3q plus 1 whole cube, और इसको जब हम लोग सिंप्लीफाई करेंगे तो फाइनली इस फॉर्म में इसको लेके आएंगे, and then we can write 9m plus 1, and m is some integer obviously because this whole expression will always be n. Alright, so now let's see the third case where r is equal to 2. So in this case a cube will be equal to 3q plus 2 whole cube, and finally we'll put it in this form, and now we can write 9m plus 8, where m is an integer. So this is how we can say that the cube of any positive integer is of the form of 9m or 9m plus 1 or 9m plus 8. Alright, so we finished this video here. Keep watching, and in case अगर आपको कोई भी डाउट कोई भी क्वेरी होनी पूछनी है तो you can drop it in the comment box and I'll be coming with the solution for that. Thank you so much, and in my next video we'll be solving exercise 1.2. Thank you.